32 says here that f of 3 is equal to 7. F prime is equal to sine of 1 plus x squared over x cubed minus 2x. And we want to know ultimately what is f of 5. Right? So the being given the derivative here, if we have our f prime function, we could certainly find f here as long as that was something that was integrable. Focus. We'll go with that. Okay. Go ahead if you want. So bottom line is we could certainly integrate that and find f and then plug 5 into it and get an answer, but the problem is this particular integrand here looks like it might be rather difficult to find an antiderivative for. So remember, ultimately, if we're trying to find an antiderivative or integrate any derivative function, okay, we can write an equation for it using that integrand. Because ultimately, if I wrote this, okay, wouldn't that right there represent an antiderivative for this function? True. Now what else we want to have happen, remember, is we want this to go through 3, 7. So that means if we let our lower limit be 3 and our upper limit be t, and we let that be our function f of t, if you will. And again, if we were to anti-differentiate this, we'd get the antiderivative, which is f, evaluated at 3 and t, and ultimately if we added a 7 on the end of it, okay, that would be an antiderivative for this function. So remember, we had some of these in AB. This is an AB problem ultimately. And again, if we can't find an actual antiderivative, we can write it an integral function. And again, keep in mind the lower limit size is going to be the x value of the initial condition, and then we're going to add the y value over here. The reason being is because, again, this right here, the antiderivative of this gives us f, but we also have to satisfy the initial condition 3, 7. And if I were to put a 3 in here for t, I'd have 3 to 3, which means this whole integral would be what? Be 0, and I'd get 0 plus 7, and I'd get 7. So everybody agree that this satisfies the initial condition? If I put a 3 in here, would I get 7? Yes. And again, this part here is the antiderivative part. Now, knowing that, ultimately I want to find f of 5. Well, then isn't my f of 5 the answer to this? True. And since this is on the calculator part, it's a calculator problem. If we put our integrand here, being sine of 1 plus x squared divided by x cubed minus 2x. Oops, there's some parentheses maybe. Right here. And looks like that, which ultimately will correspond to letter C, it looks like. Oh, I forgot to add the 7, sorry. Thank you. So let's add 7, so not C. And it should be 6.992, which ultimately is D then. And don't forget about the 7. Alright. So, again, if we cannot find an antiderivative for a particular function, we can always write it as an area function. Okay? And again, satisfying the initial condition is going to mean lower limit is the x value of the initial condition. Going to add the y value over here so that we get the fact that if I put in a 3, I'd get 7 in this case. Okay? And then from there, once we have that written in our area function, we can find any values we want to because it's a calculator problem. If it wasn't a calculator problem, would we be able to find this number? Others? 29 to 32? 37. We have a cross-sectional area problem. You got the base of the solid is in the enclosed by the graph of 3 times x minus 2 squared, which ultimately has a vertex at 2, so it's 2 to the right. And if we were to put a 0 in here, we'd get 12. So 0, 12, we're at that point. If it's 0, 12, then 4, 12 would be a point. So here's our parabola that we're getting. And it says that it's the base of the solid. It's in this region enclosed by this graph and the coordinate axes. So ultimately our area in question is this part. So we don't really even need this other branch over here. So we'll just look at this part right here only. And it says every cross-section perpendicular to the x-axis is a square. So again, if I were to draw a slice here, and I were to draw some kind of three-dimensional square coming out of here, my picture would look ultimately something like that. Alright, so again, the slice that we draw is perpendicular to the x-axis, and that slice, that length of that slice is going to be the same distance coming out of the paper at us, and also across the top, because we're going to create, by doing this, a square. And so again, if I were to draw it, closer to this point or closer to this point, obviously the squares are going to be different sizes because they're going to depend on what the height of the function is at whatever x value is in question here. So bottom line though is if we can write an area formula for one square, then we can sum up the areas of all the squares with an integral. So the area of one square, wouldn't it just be 3 minus x squared all squared? Wouldn't that be the area of one square? One dimension of it will be that. Another dimension will be the same because it's a square. And ultimately if we integrate that on 0 to 2 dx, dx being the thickness of each square, which is infinitely thin, and again 0 to 2 because we're going from the origin to the 2, 0 point where we have the vertex. And from there, again you can do that one by hand obviously, but I'd just do a calculator if I were you. It's a calculator problem, don't waste any time doing it by hand. So in our integrand we have 3 times x minus 2 squared squared. 57.6. Which ultimately gives us E. Alright. So again, this is an AB problem, also cross-section. Cross-sectional area problem. Questions on any parts of that one? What else? Evan? 33, we got a infinite series. And it says if that infinite series converges, then which of the following is true? And in the first one, it says that our A of n converges. So ultimately we want to know, is it true then that A of n converges? If we know that the absolute value converges, okay, does the actual sequence converge? What would you say? Now, if you remember, well, one of the things that we did here, we figured out that if a sequence converges, and then we found that its absolute value also converges, then not only does it converge, it converges absolutely. So if we know that the absolutely part converges, then that means that the A of n would converge as well, wouldn't it? Okay. So this would be a yes. And then A of n is absolutely convergent. Well, again, knowing that that converges is the very definition of absolute convergence for our function, isn't it? So So therefore that would be a yes. And then finally, if I have the opposite of A of n, and we want to know, does that converge also? And as stated up here, we know that the absolute value converges. Okay? So with either of these, okay, if the absolute value converges, then these are what the absolute value would come from with these two options. So if this converges, then these two options also would converge. Okay? Therefore, that would be good too. And is there an option for all three? So E. Good. What else? 237. Huh? 36, we have, and just for the record, that would be a BC problem. Convergence. 36, we have let f be a function whose seventh derivative is 10,000 cosine x. And it says that if x equals 1 is in the interval of convergence of the power series for this function, then the Taylor polynomial of degree 6 centered at 0, 0 will approximate f of 1 with an error of not more than what? So keep in mind that this is that remainder theorem that we worked with that ultimately depends on the n plus 1th derivative. Right? And so remember what our work looks like on that. We have our x to the 7th over 7, and we have our m value out here. Remember, m is the max value of the 7th derivative in this case, because we're doing a 6th degree polynomial, it says. So they've given us the means to, we already know the 7th derivative here. And ultimately, on the interval of convergence, we're looking at 1 as our point in question. We're going out 1, if you will. So that means that we need to look at the 10,000 cosine x. If we go 10,000 cosine 1, that would ultimately be 10,000 then, wouldn't it? Okay. So that value being the maximum value of the 7th derivative. And then ultimately the question here then is, what do we want that error to be less than? Remember that the interval here is 1, because we're going from seemingly 0 to 1. Does it say it's centered at 0? Yeah, it's centered at 0, so going out to 1 would be the x in question. So if I do the 1/7, we'd ultimately get that. Now, the question though is, that doesn't appear as one of the answers here, so there's something that we got to make sure that we adjust here. If you look at your, go back to that definition again. Remember, there was two different types of problems we had. Let's take another look at the definition here. All right. So ultimately, in our definition here, we know that again, m is the m and r are constants. We know that r can just be 1. All right. And ultimately, in this remainder theorem, we have our m here again was that same value, and we have our we're doing the 7th here because we're we're doing n equals 6, if you will. So it's going to be our 7 and oh, I know what the problem was. Anybody else see it yet? Yeah, the factorial. That would help. Let's try that again. So ultimately, if we do 1/7 factorial, that's going to give us a lot different answer. So that's why we had an issue. Let's try that one then. So 1/7 factorial, and then if we multiply that by 10,000, we get 1.984, which is D. So that, assume that corresponds to the right one. Yeah. So 1.984. So again, in terms of that that remainder theorem, I guess the key elements that we got to worry about here are if we are looking for the actual error. Okay. And again, this is a 1 because this is how far away from the center that we are, because we want the approximation at 1. Okay. And in general, our general form is this. If we're looking at a 6th degree polynomial, keep in mind if we were doing this with a 3rd degree polynomial, then these would be 4 and 4 factorial, if you will. Right? Okay. So whatever the degree of the polynomial is, we're always going to be 1 more for our power and factorial part. And then again, the m, keep in mind, is just the maximum value of the 7th derivative on the interval. Okay. And we know that cosine, 10,000 cosine, it's going to be a maximum at, I mean, the maximum it's going to be is actually at 0 itself. It's going to be 1 there, and the cosine is. And so therefore 10,000 is the biggest value we're going to get. And then from there, we just calculate. Okay. Others on that one? Others? 29 to 37? 37 says if f is an antiderivative of tangent squared x over x plus 1, x squared plus 1 that is, and f of 1 is a half, then what is f of 0? Right. So ultimately, again, f is an antiderivative of this function. So really, isn't that fairly similar to that one we did a minute ago, isn't it? Couldn't we write the integral from 1 to t of tangent squared x over x squared plus 1 dx plus a half equals our f function, our antiderivative. So again, even if we may or may not be able to anti-differentiate this, but we can still find a value because we can always write it as an area function. Because again, f is an antiderivative of this, satisfying the initial condition 1 equals a half. So again, 1 in here. If we put a 1 in here, the whole area would be 0. We get 0 plus a half would give us the 1/1/2 point. And then from there, if we want f of 0, then just plug a 0 in and calculate. According to this, if we calculate it, it should be 0.155. So let's check it out, see if that's a fact. It's good. And I didn't forget to add the half this time. Okay. Anything else? 29 to 37.